Good afternoon, everyone, and welcome to the Cloud Techno webinar. My name is Richa Mishra, and I'll be your co-host for this informative session. So, we all know that disaster recovery is an essential component of a business continuity plan. Now, for any disaster plan, it relies on two things. First, the recovery time objective, that is the time taken to recover from any disaster, and the RPO, that is recovery point objective, that is the maximum amount of data the organization can tolerate losing it. So when the RTO and the RPO are extremely high, then just taking the backup and restore won't be useful for any disaster recovery plan, as it may take longer time to recover and may loss in data as well. So today we will see how Mongosync can help in such situation and ensure that MongoDB is highly available and safe during disasters. And more insights will be shared by our presenter, that is Ms. Ishita Nenwal, Mr. Pankaj Holaria, and Mr. Pradeep Desari. But before handing it over to them, let me inform you that this session will be recorded for the future references. And secondly, if you have any questions during the presentation, please make a note of it, as we have set a dedicated time for the Q&A segment at the end of the webinar. So now let me request Ms. Ishita Nanwal to please take over the stage and share your expertise with us. Thank you.
Thank you so much, Richa. So, a very good evening to one and all present here. Let me introduce you all to the topic for today's webinar. It is MongoDB High Availability and Disaster Recovery using Mongosync. Okay, so let's now dive into the agenda. In today's webinar, we will be discussing an overview of MongoDB and its deployment architecture. Then we will provide an introduction to the tool Mongosync, an architecture, some key features and use cases, benefits of this tool, and at the end, we will see a technical demonstration for the same. Okay, so now let me introduce you all to the team for today's webinar. It's Ishita Nenwar, that's me, who will be guiding you all through the presentation today. Then it's Pankaj Holaria, who will be introducing and showcasing certain scenarios to you all at the end. And then it's Pradeep Dasari, who will be guiding you to the configuration for this tool and will provide you what all we require to configure the tool. So let us begin. First, let me introduce you all to MongoDB. Now, MongoDB is a popular open source non-relational database management system that falls under the category of document-oriented databases. Now, in document-oriented databases, data is stored in a format which is very similar to JSON, and we call it BASIN format. Now, BASIN stands for binary encoded format. BASIN is very scalable and highly flexible and can vary in structure from one document to another. MongoDB is a NoSQL document database, and this means that it stores data in JSON documents, which are self-contained units of data that can contain any type of data, included nested objects, arrays, and strings as well. So now, this feature makes MongoDB very flexible and easy to use, as you don't have to define a schema for your data before you start using it. Also, this database can be scaled horizontally to handle large amounts of data and traffic. It can also be deployed in a variety of architectures, including replica sets, sharded clusters, and Atlas clusters as well. Moving forward, let me introduce you all to the architecture types of the database MongoDB. So the first one stands for standalone type. Now, what is a standalone type? MongoDB instance is a single database server that runs on a single machine. Talking about standalone type, it's a very simple and straightforward setup, and also is often used for development and testing environments. Now, why in development and testing environments? Because very high availability and scalability is not required there. The second type of architecture that we have is replica set. So a replica set is a group of database servers that work together to provide data redundancy and failover capabilities. Now it consists of a primary server and also more than one secondary server. So in case one of the primary server fails, any one of the secondary server will act as a primary server. By doing this, we will be able to manage any kind of disaster. Also, the data will be highly available to us. The last architecture type that we have is sharded. Now, what is sharded? A sharded cluster is a distributed database system that horizontally scales the data across multiple machines, or we can also call them as shards. It is designed for handling very large volumes of data by dividing or distributing the load amongst the multiple shards. And each shard can be a replica set, providing both horizontal scalability and very high availability to us. And of course, it is used where large scale applications are running, for example, big data analytics or any massive or any scenario with massive data traffic. Okay, so let's discuss about what is the problem statement for the day. It says to ensure real-time data synchronization across our DR clusters in different regions without any manual intervention. So MongoDB downtime can be very costly and can affect our revenue, also the reputation and productivity as well. So the traditional recovery systems or the methods were very slow and complex, leading to a very large or extended downtime during any disasters that occurred, right? So the question we address here is how can we recover the MongoDB databases faster than usual? So Mongosync is a tool that offers real-time synchronization and automated recovery, in turn that will minimize our downtime and ensure business continuity as well. So in this presentation or webinar, we are going to explore how Mongosync achieves this and its real-world applications as well. Moving forward, let me introduce you all to the tool Mongosync. So MongoDB cluster to cluster sync is called Mongosync. It is a free open source tool that can be used to synchronize data between two MongoDB clusters. It is a powerful tool that can be used to create disaster recovery clusters as well, and also is helpful to migrate data between two clusters and create read replicas as well. MongoSync is very easy to use and can be configured and synchronized according to our own needs. Also, it is very different from the traditional type of databases, and this tool will help us to migrate the data from our source cluster to the destination cluster very easily and flexibly. Moving ahead, we have an architecture of this tool. So now over our screens, we can all see two clusters. One is our source cluster and the other one is our destination cluster. The source cluster lies in region A and the destination cluster lies in region B. We can see MongoDB in both of these clusters. Now what is happening? We can see the file transferring from the region A to region B. What we are doing here is we are replicating the data that we have in our source cluster to the destination cluster with the help of the tool MongoSync. Traditionally it was very difficult to do the same, but because of this tool we can do it very easily, and that is why we are introducing this tool here. Okay, so now for MongoSync, let me introduce you all to some of the key features that it includes. So the first one says continuous data synchronization. Now it means that MongoSync will continuously monitor the source cluster for changes and apply those changes to the destination cluster, of course, in real time. Now what will happen by doing this? It will ensure that the two clusters that we have are always in sync, even if there is a high volume of data or traffic. Next key feature is incremental data synchronization. Now, incremental data synchronization means that MongoSync will only synchronize the changes that have been made to the source cluster since the last synchronization. Now, why is this helpful? This will reduce the amount of data that needs to be transferred between the two clusters that we have, which in turn can improve performance and reduce bandwidth usage as well. Next, let me talk about its flexible configuration. So Mongosync can be configured to synchronize all data between two clusters or to synchronize only specific databases, any specific collection, or any specific document. Now, this feature makes it a versatile tool that can be used at a variety of different purposes and for a variety of different purposes. So these were some key features that this tool holds. Next, let me introduce you all to the use cases of the tool. The first use case that we have here is data backup and disaster recovery. So data backup and disaster recovery are two very important aspects of any IT infrastructure. Data backup is the process of creating copies of data so that it can be recovered in the event of a loss or a disaster, we can say. Now, disaster recovery itself is the process of restoring operations after a disaster, such as a hardware failure or a natural disaster. So, Mongosync can be used to create data backups and disaster recovery clusters. For example, it will help us to create, for example, we can, create a production cluster. Now, for the recovery for the production cluster, we can create a recovery cluster. If your production cluster fails, you can switch to the disaster recovery cluster and resume all the operations with a very minimal downtime. Next, we have data migration. So data migration is the process of moving data from one environment to another. And I'm sure we all know this, right? So this could be done for a variety of reasons, such as to move our data to a new production environment or to migrate data to a different cloud provider, or also to consolidate data from multiple sources. So now MongoSync can be used to migrate data between two MongoDB clusters, and this is very helpful for migrating data to a new production cluster or for migrating the data to a different cloud provider as well. The last use case that I will discuss today is new DB environment. So MongoSync can also be used to create new DB environments. For example, you could use this tool to create a development environment that is kept in sync with your production environment. This can help to ensure that your development environment is always up to the date with the latest data and the latest changes that are made. Moving forward to some of the benefits of our tool MongoSync. So the first benefit that it has is data consistency. Now, what is data consistency? It is the state of having the same data in two or more places. So MongoSync helps to ensure that data consistency by continuous synchronization or synchronizing the data between two MongoDB clusters. This means that will always be the data will always be same even if there is a high traffic or high data traffic or very high volumes of data. Next benefit that we have is scalability. So scalability is the ability of a system to handle increasing amounts of data and data traffic. MongoSync is a scalable tool that can be used to synchronize data between two MongoDB clusters of any size. Next, we have flexibility. So what is flexibility? It is the ability of a system to be adapted to meet different kinds of needs. Now this tool MongoSync is very flexible and also can be configured to synchronize all data between two clusters or to synchronize only specific databases, any specific collection or any specific document. The last benefit that I am going to talk about is reliability. So reliability is the ability of a system to perform its intended function without any kind of failure. MongoSync is a reliable tool that has been tested and used by many organizations. Now, data consistency can help to reduce errors and improve the accuracy of data. Scalability can help organizations to grow their business without having to worry about their MongoDB, without having to worry about their infrastructure of database. Flexibility can help organizations to adapt their MongoDB infrastructure to meet their changing needs as well. And lastly, reliability can help organizations to avoid any kind of downtime and ensure that their MongoDB applications are always available up and running. So now we have Pradeep with us, who's going to uh, guide you all for the configuration of this tool that we have, and we'll also discuss about what is needed to begin with the configuration of Mongosync.
Yeah. Thank you, Ishita. Good afternoon, everyone. Hope everyone doing good. So now, as Ishita covered theoretical part of MongoSync and what are the benefits and use cases of it. So I'm going to cover some of the needs before you're going to start using MongoSync and before start using it. So let me share my screen. Yeah, 1 second. Yeah. So yeah. So I'm going to cover what are the needs to going to configure the MongoSync and what are the configuration we need to look into before using the MongoSync. So first point is we need actually two MongoDB clusters. The MongoDB cluster, it can be any MongoDB, like it's an Atlas MongoDB or any self-managed MongoDB which is deployed in any virtual machine or any Kubernetes cluster. So in this demonstration, we are actually using self-managed MongoDB cluster which is deployed in GKE, which is a Kubernetes service of Google Cloud. So in this demonstration, we're actually using Google Cloud. And the next point is, as we have a MongoDBs in uh, different clusters, now we have to make sure there is a connectivity between these two clusters. So in a bit, I'm going to show you how we need to look into this connectivity check. So what are the things you need to consider while deploying these MongoDB clusters? And the third point is the MongoDB utility itself. So I'm going to show you how the MongoSync configuration should be done and how you configure and how you deploy it. Now, as I said, like we are using GCP cloud provider for this demonstration. Let me log into my console. Let me reshare my screen to show you the GCP cloud console. Yeah. So this is my GCP console. Now I choose my Kubernetes engine. This is a GCP console where you can see your Kubernetes clusters. So as I mentioned, we created two Kubernetes clusters in different regions. So the naming convention, it actually shows the main cluster and DR cluster. So as we're going to show you the entire DR kind of setup. So we created two Kubernetes cluster in different regions, and we these Kubernetes cluster actually deployed in installed in same VPC, but at different subnets. In GCP, the subnets are actually regional level subnets we create. So so to make the first point is we deployed the MongoDB here, and the second point is the connectivity between these two MongoDBs. So so you to make your MongoDB communicate each other, you have to expose your application internally by using internal load balancer. For that, we actually need two IPs of your subnet. Whatever your subnet, we will pick those two IPs of your subnet. So why we are using two IPs of your subnet? Because we are currently using replica set architecture of MongoDB. In replica set architecture, you will go into have one primary and secondary. In a moment, I'm going to show you that what is primary and what is secondary, and I will going to show you the IP addresses also. So to clear that, let me open my main cluster. If I come down to the networking part, in networking we have subnet. In subnet, I have this CIDR range. So I'm going to pick one of two IPs of from this, and we will make those as an internal load balance. Now this is our main cluster and DR cluster, which are situated in different regions, and we already deployed MongoDB in main cluster and DR cluster. So let me go to my terminal. It's a cloud shell actually. So I'm connected to main cluster. Here we deployed our main MongoDB. Yeah, as I mentioned, we need two IPs. That is because of replica accept architecture is actually it's like a high availability MongoDB. So you have primary and secondary. So and you have arbiter also. Arbiter is something which actually elects your which is primary and which is secondary. So let's say one of your primary pod goes down, the arbiter automatically selects the second one. The secondary will act as a primary. So that configuration, default configuration done by handled by arbiter. So as I told you, so we need two IPs from this CIDR range. From this CIDR range, we took these two IPs, 10.128.10 and 11. So these, as you see, these are in external IP. So we are exposed this IP, we are exposed this application internally, and also this internal load balancer can accessible within the VPC from any subnet. You can customize your configuration also by using firewalls. Let's say you want to do other application don't want to talk to this MongoDB, you can use firewall those to customize it. Now, so we have two Kubernetes clusters, two MongoDBs, one in main and one in DR. So now the next point is you expose your application. The next point is you need a user in main MongoDB and DR MongoDB. User in admin database of main MongoDB and DR MongoDB. So which is actually used to make communication between these two. So with that user, you will create some configuration file. In configuration file, you use your which is primary and which is secondary for Mongosync. So now we're done for the Mongosync part. We entire thing actually happening with using Helm charts only. Now we have MongoDBs. Let me show you the main configuration of Mongosync. So in Mongosync, you have your main configuration file, which is so you in that configuration file you mention which is your main MongoDB, which is your secondary MongoDB, or you can call DR MongoDB. So here we have cluster 0 and cluster 1. So cluster will default will act as a primary, cluster 1 will act as a secondary. So as I mentioned, this is a string actually. So in the string we have primary, we have IP address of both main MongoDB and both DR MongoDB. Now, as I mentioned, we need one user and password from admin database of main and DR. So we created a user called sync test for better understanding. Use sync test only. So sync test is a user and sync test is a password. And you can see at the end the auth source is admin. It means the user is actually located in admin database. So in the third point, we are storing our logs in particular directory. It depends on you where you wanted to store your logs, and the verbosity also same. So we are actually using warning logs only. You can go with info or error verbosity also. So this is the configuration, main configuration for the Mongosync. Now, Mongosync, we are actually creating a Docker image of Mongosync by using binary file of Mongosync. So we are customizing Docker, we are customizing our Mongosync according to our need. You also can customize your Docker file. I'm going to show you a Docker file also. And we creating a Docker image and pushing it to our artifact registry. And with the simple Helm charts, just changing registry image registered and replacing it with our artifact registry, we are deploying it in DR cluster. So for safe side, we are using DR cluster only. Let's say our main region goes down, your Mongosync will be there. So that's fine. That's a good practice actually. So this is our Docker file. So before that, so here I have a bin directory here. Inside that, I have a Mongosync binary file. So in the same way we are doing in Docker file also, we are copying just that binary file into a Docker image, and we are at the end we are running a command to start Mongosync. So if you see here in this point, we are copying our binary file into the working directory. Now at the end, this actually the main part is this one. So when you start your Mongosync, you create the configuration file, you create your configuration, and this by using this command, you start your Mongosync. So this is configuration part done. Now now these are my Helm charts for Mongosync. So as I mentioned, we simply created our Mongosync just using a Helm create Mongosync. So our Helm charts are created. Now I'm going to show you the values.yaml where we actually replacing our Docker registry URL. So here image registry as we are changed, and we pushed our Docker image to our artifact registry, and we are deploying from here. Now my colleague Pankaj will going to walk you through some of the scenarios. So now we're done with the configuration part, and we have installed everything. Now Pankaj will going to show you some of the scenarios, like how you can use your Mongosync according to your usage. So yeah, Pankaj.
Yeah, thank you, Pradeep. So hi all. So I will be taking the lead to demonstration of Mongosync. So allow me some time to share my screen. So uh, So for the demo, we will be demonstrate Mongosync with three different scenarios. The first scenario involves syncing a particular collection from one MongoDB to another. And in the second scenario, we will show how to sync a collection while excluding a specific collection. And the final third scenario, we will demonstrate a full sync scenario. So let's begin with the first scenario. So let me reshare my screen. Just a minute. Yes. So we have two clusters. So we need to change the context to switching between the cluster. So let me jump to the main cluster. Now you can see there are only a default database because I didn't create any database. So let's create a database. Okay. So I have created a database name library, and inside this I have created a three collections: the name, author, book, and publisher. You can see as well. So just so DBs, you can see there's a library database, and inside this we can check collections as well. So these are three collections as well. So I didn't start the Mongosync yet, so there's no sync happen yet. So let's verify this also. So let me jump to the second cluster as well, and let's verify this. So if you can see, there's only a default databases. So let me start the Mongosync. For this, Mongosync. Just a minute. So while Mongosync is deploying, let me share one thing with you. So Mongosync operates in different states, including idle, running, and pause. So in this demo, we will be primarily focusing on these three states only. When we initialize Mongosync, its default state is idle. The to start Mongosync, we need to make an start API call, and we can also check Mongosync progress through progress API as well. So uh, let's see Mongo. I think Mongosync is deployed. Let's cross verify this thing. Yeah. So you can see there's a pod is Mongosync pod is running. So let me access the pod. Give me just a second. Okay. So you can so let's check the progress of Mongosync. So you can see here the Mongosync is now on an idle state, right? So we need to basically start the Mongosync through the Mongosync API start API. So let me start this. So now you can see actually when I'm starting the Mongosync during this time, I just passing a filter as well. So you can see there's a one keyword include namespace. So let me explain this. So in a filter, basically two keywords we can pass: include namespace and exclude namespace. So include namespace when you want to basically sync a particular collection from a database, then you can use the include namespace keyword. And if you want to exclude a particular collection, then you can use the exclude namespace. So let me start this. So you can see it's synced, and the response is a success and true. So let's verify on a DR cluster. So just a minute. So now you can see the library and the Mongosync reserved for internal use database is created. So let me share info about the Mongosync reserved for internal use database. So Mongosync reserved for internet database use database is used by Mongosync to store in internal state information. This information is used to track the progress of the sync operation and ensure that the data is synchronized correctly. So let's verify our first scenario as well. So let me connect with the library database and just see the collections as well. So now you can see there's only one collection because we use a include namespace keyword, and we just pass the author collection, and so the author collection only synced here. So this is our first scenario. Before going to a second scenario, let me share one thing that there's a quick note. Please keep in mind that you cannot change the filter while Mongosync is running. If you wish to modify the filter, you will need to stop the Mongosync. So let me stop the Mongosync first. Just a minute. Mongosync stop, stop, stop. Just a minute. Sorry. Okay. Also, we need to clean up the databases which is created on a basically DR cluster. So let me do this also. Let me do this. Delete. Okay. So for this, I need to jump to the second cluster and remove the databases as well. So now I just dropped those databases. Let's see. Now you can see it's back to the previous state, and we can start the second scenario. So for this, I need to again basically deploy the Mongosync. Let me deploy this. Okay, it's deployed. Okay. MongoDR. It's deployed. Let me access this as well. Let me access. So let's start the second scenario when we want to basically exclude a particular collection from a database. So you can see I used a exclude namespace here. So now the status is a success, and let's verify on a secondary DR cluster. Now you can see there's only two collections here because we exclude the basically publisher collection. So this is our second scenario. Let's move to a third scenario. For this, let me stop the Mongosync. So it's back to the previous state. Let's apply the third scenario. So the third scenario is a full sync scenario when where we want to basically fully sync data. Full sync means all the database and all the collection will be synced. So let's start this as well. Okay. So now you can see I didn't pass any filter here. So if we didn't pass any basically filter during basically start the Mongosync, so by default it will be on a full sync scenario. So let's start this. So now again the response is success and true. So let's verify this also. Just a minute. Let's verify this also. Now you can see all the collections are synced properly. Okay, so this is the three scenarios. So let me share some points as well. Let me reshare my screen. So points to be basically remember during this basically syncing a Mongosync. The minimum supported server version is a MongoDB 6.0.8, and the source and destination cluster basically must have the same release version. And when basically we are syncing from source to destination cluster, during this time, we should keep in mind the destination cluster must be empty. And our Mongosync, basically Mongosync only supports a two type of architecture. One is a replica set and one is a sharded architecture. So let me conclude all the things as well. So Mongosync is a powerful and flexible tool for synchronizing data between basically MongoDB cluster. It offers a number of benefits, including continuous data synchronization, data consistency. So in this webinar, we have shown you how to use Mongosync to sync a particular collection, excluding certain collection while syncing, and perform a full sync. So we hope that the webinar has been giving you a better understanding of how to use Mongosync to meet your data synchronization needs. Yeah, thank you all. So now I am handing over to my colleague Richa.
Thank you so much, Mr. Pankaj. That was an insightful session, I must say. So let's move to our Q&A segment. If you have any questions, please feel free to ask our presenters. You can unmute yourself or you can type in the chat. And I can see Mr. Mohit has asked, what do you mean by destination cluster must be empty? Pradeep, if you can answer it. Mr. Pradeep, you there?
Yeah. 1 second. Yeah. Thank you, Mohit, for the question. So, what is mean by that is, so when you start your the synchronization process, or when you start the Mongo sync, so before that you have to make sure that you have to your destination MongoDB, which is a DR MongoDB, that should be deployed, that should be newly deployed, that should be fresh one. So let's say you have already some database in your DR cluster or DR MongoDB. So when you start your Mongo sync, it will say like the destination must be empty. Like these kind of errors you will get. So you have to make sure that when you start your Mongosync, the destination MongoDB should be empty. So the next question is, what if I synced once and the collections are already copied? So I haven't get you actually. So what if I sync once and the collections are already copied? So the already collections are there, right? The question is not clear, Mohit sir.
I think we need to clean all the collections as destination must be empty.
Hmm.
Is that correct?
Yes,
That's
yeah, correct, Richa. Since we've already said that the destination must be empty.
Ishit, I'm so sorry. I'm not able to hear you. All right.
One more question is from Prabha
Yes.
Chapati.
Sure.
So is this sync one way or bi-direction? So yeah, it is a one direction, unidirectional only. So let's say you are syncing your data from one MongoDB to another one. So you can't again at the same time you can't reverse like from destination to source. It's a unidirectional only. Or let's say if you want to change that, so when you're so as I mentioned, it's a DR kind of setup. So when your primary region goes down, so you can go there into Mongosync pod. You can simply run one command, so it will reverse your replication.
Pradeep, can you hear me?
Yes.
Yeah.
Yeah, the question is, can we use the DR for read-only purpose or any other purpose?
You can use see. So it's like a you're backing your entire MongoDB and what we call and collections and tables also. Okay.
Mm-hmm.
So now you wanted to use, you can create your any other database also. So you can use active passive also. But let's say you created some database in DR or your passive MongoDB in DR MongoDB, that will not reflect to your source. As I mentioned, it's a one-way direction, right?
So that I
It will
understood. Okay, can I use the DR for read-only purpose? Suppose if I want to read only data from the DR, So can application read the data from DR?
Yeah, that is possible. If you're exposing that application is able to talk to the DR, then that is fine. You can talk.
Possible, right? Okay. Thanks.
Right, any more questions?
And one more question is from Ajay. Another
Question
Mongosync
from
supports.
Jayanti as
some
well.
information. Yeah, it's a official only. It's actually you have a official documentation for Mongosync. It is officially available from MongoDB. Jayanti Vikas is saying, can we do reverse Mongosync from DR to Lemon? Yeah, that's what I mentioned you mentioned just now, Jayanti.
Pradeep, one more question. What if there is a more lag on the DR side?
More lag on DR side.
Yeah.
Means like the replication lag you're talking, like primary to
Yeah,
secondary?
the replication lag, correct.
No, it will when you deploy, let's say you created a database in your primary, or you added a collection in primary, it will be replicated within seconds.
What if assume the workload has been increased when it goes to production, right? Assume workload has been increased. What if there is a lag on the the DR
Yeah.
DB?
So when you do it first time, the lag will be there. Okay, it will take some time to replicate, but once it is synced perfectly, then it will not take much time.
So after that, we will not find any lag, even if the workload increases on primary.
If the data is loading very much high, so there might be some lag.
It
So
depends
in
upon
that
the
case,
network connectivity and size of data.
Yeah.
so in
So it
that case, we
actually
need
works
to.
on your
So in
operation
that
logs.
case, we need to wait for the lag to be released, right?
Yeah.
Okay. Thanks, Pradeep.
Thank you, Pradeep.
Right, any more questions anyone want to ask?
Mohit ji, I think you got your answer. Yes, collections are already there. So we are talking in DR cluster.
All right, I think we are good to wrap up the Q&A session. But if you have any further questions, you can always email us and we would be more than happy to answer your questions. And our email ID I'll post in the chat. Just give me a minute, please. Here we go. So as we are at the conclusion of this webinar, firstly, I would like to thank our presenter for sharing their expertise with us. And secondly, a big thank you to all of the participants who joined us. Thank you. Have a great day, everyone.
Yeah, thank you everyone for joining.